I'm Paul Rako. This is the Atmel Edge, the show that makes you well-rounded and well-grounded. Today we're going to do Sprinkler 102. We're going to do a teardown of this little sprinkler controller that I got so frustrated with over the last year or two. We'll see what's inside it. Maybe we can figure out what kind of chip it uses. Check out the construction. The mechanical design looks pretty good, but I certainly don't like the user interface. The small size means that the user interface isn't as intuitive as I'd like it. Hopefully, in our redesign, I'm thinking of using a SAM D20 ARM-based microcontroller that we make here at Atmel. I want it more like this Big Ben clock that's simple to set and just very intuitive to use. So let's get started. Okay, to do our little teardown, I've got my Leatherman Crunch here. If you have the funds, I highly recommend picking one up. It's a locking plier. Be careful calling it a vice grip because that's probably patented by the vice grip people. And it's $69, and it has a Phillips blade, and it's got this little straight blade, and they're locking. See if I can show it here on the B-roll. So the first thing, we'll use this little straight blade. You can slide the cover down. You know I like these. And remove the terminals for the AC 24 volt AC input. In case you're wondering what the sprinkler clock does, I brought a valve, a sprinkler valve. Goes into a unit here. This is the plunger part. And this solenoid here gets operated. You can see similar magnetic sizes. So this solenoid here is operated by the 24 volt AC triacs inside this product. Turn it on and off. So let's see what we have. It's running now. Should we leave it on? Probably. Now we'll switch from the straight blade to the little Phillips. Take these 4 screws off with the Phillips. All right, that's the last screw. So let's kind of carefully, oh, look at this. Beautiful. Like I say, I love the mechanical design of this. Injection molded, some kind of pad here that's been run through. I'm not quite sure why. You can see this system. This is how you screw it in. There's a tab here. If we move this paper, you can see it a little better. So you can put one screw in your wall there. And then it's kind of clever. The other screw you get at, might as well take these batteries out finally. You get at through the bottom of the battery compartment. So you can really nail this thing to the wall. It won't go anywhere. Finally fading out. It's got a hold up cap so you can change the battery without having to lose everything. One of the big problems is it is volatile. Now let's see what we're looking at. Well, I don't see any screws. Oh, okay. The screws that hold the cover also pin the board here in the corners. So that's kind of a nice feature. So let's ease this out. What do we have? Okay. So here's the main board. It's got this SIP inline connector, and there's a bunch of pins. I don't know if you can see that. You can hear them probably better than you can see it. Then here's some more screws holding in the LCD part of the display, and then the buttons, which makes sense. You'd want to screw that in nice and solid so when you press the buttons, nothing's giving too much. Here's still, well, these are the triacs in TO92 packages, which is kind of surprising. They didn't use surface mount. When you do consumer products, cost is everything, and using a paper phenolic board like this is less expensive, and rather than having a lot of copper on it to take away heat, they found out you could use TO92s. My design, I just use surface mount and a FR4 4-layer board. It's like, come on, let's be modern. What else? Terminals, little ISO fuse, the European style, which I'm not too fond on. I'd use an automotive for that matter. All right, might be time for a break, but why stop now? See if we can get screws are different sizes, which is, well, I guess it has to be. There's a short screw and a long screw. The shorter ones are in the display board. There's quite a few screws here, and that's indicative of the good mechanical design of this product, where they're making sure that there's not a lot of stuff that flexes and goes wrong. Here comes the last screw. That's the last short screw. Now what happens? Very carefully. Okay, this is nice. Once again, nice injection molded little clear plastic window, so that's kind of interesting. Maybe for water, not sure why. Here's the guts of the thing. It doesn't have the driving, but all the smarts are in here, probably under this LCD. There's no chip shown here. Well, so here's a crystal. Looks kind of like a watch crystal size. It's hard to say. Ah, here comes the... As you'd expect, you have gold plated here, gold immersion, and then little carbon dots. And that carbon loaded plastic shorts these interstitial, these gold fingers are interlaced like that, so that when you touch it, it shorts the two, and then the microprocessor can read it. No apparent microprocessor yet. Well, this is why I love my Leatherman Crunch. You fold in this, bring out the, don't call them vice grips, get two companies mad at you. Get the locking plier part, and let's see if we can straighten out these tabs. This is more an eyesight problem than anything else. So I think I've lined up the tabs. I'm pushing them out. So they had little tabs on this metal housing here that went through the board, and they were just twisted to hold it in. So let's pop this out now. We can. There we go. And so that we carefully, okay, so the metal case comes out. That's nice. Ah, here we go. Ah, unfortunately there's foam back here, which is kind of neat. That keeps the LCD pressed up against the bezel. Here, I have no good pointing instrument. I have my beautiful pen. Right there, this little blob of black plastic. This is a chip on board. COB is the acronym, which means that they've taken a die and they've bonded that die to the circuit board. And then they do bond wires just like when it's inside one of the Atmel packages. And then they put a blob of epoxy over it. And Atmel sells die for this exact kind of reason. There's no way of knowing, unfortunately, what microprocessor's in here. It's volatile, so that makes me think it's not an Atmel where we have EEPROM and flash and all this stuff where you could store the program of your sprinkler, and when power goes out, when the batteries die, it wouldn't need to be reprogrammed from start. So there you go. It's not a bad little design. Little clear plastic ribbon cable here soldered in, and it looks like this should go back together, and if I do things right, it should actually even work. So nice little design. Here's the main parts of it right here. Hopefully we'll be able to come up with something as well made and elegant as this. Meanwhile, I'll put it back together and take it back home to use. And next show we're going to get a SAM D20 eval kit with the touch. It comes with a little wing that you can put in it to do touch control. Matter of fact, it comes with two wings, so it can do both self-capacitance and mutual capacitance touch. And there's different reasons. Some works better with a glove, some works better with drops of water on it. We can play with both. That's the fun thing about prototyping. We'll get you a quick start. And eventually we'll be making our own circuit board and doing our own programming for, like I said, something more intuitive, something more like a Big Ben clock instead of a lot of programming. All right, this is the Atmel Edge. I'm Paul Rako. Thank you very much. See you next time.